Yeah, good evening, wonderful people. Special recognition to our lead mentor, Mr. Victor Kinode, who very importantly happens to be the mentor for ethical hacking track. We sincerely appreciate your presence, sir. Today, we all know what is going on today, which is our track project presentation for ethical hacking. Today, we get to see what the ethical hackers have been doing over time. They want to showcase it, and we know they are ready. Today, we will have a couple of groups. I think we'll have 4 groups presenting, but we will not dwell or waste our time. What we are going to be doing is that whichever group that is ready will go first, although we will be calling out what the groups, right? And if you look at our time, I will be your humble moderator and timekeeper, your community manager, Osis Chinedu. Our time will be giving you 15 minutes for presentation and then 2 minutes to wrap up. That is a total of 17 minutes. I hope I have the blessing of my mentor here, so that we can ensure that we become very, very timely in our presentation and then wrap it up. So please, can we start from group 1? Are you there? Group 1, are you there? If you're there, let us hear from you.
Yes, we are there. Oh,
All right.
there.
God bless you. Mr. Victor, we don't know if you can hear us. Hello, Mr. Victor. Okay, so let's just hold on a bit so that we reach out to Mr. Victor and ensure that he's present, please.
Also, do you want me to say something?
I just wanted you to say hi to us. We wanted to know that you are with us, sir.
Okay, yeah, I'm with you guys. Sorry. Hi guys. Yeah, I'm here.
Thank you very much, sir. God bless you, and thank you for your time. Please, group 1, if you are here, let us get to feel what you have. God bless you.
Please, can you call on the other group, please? I'm trying to reach out to my other member, please. They are at the place of work, so I'm trying to call them.
Okay.
All right, thank you.
Yes. Group 2, if you can hear us, group 2. Are you ready? Group 2. Group 2, are you ready? Anybody from group 2?
Yeah, we are here. Good evening.
God bless you, Rachel. You're welcome. Okay, so thank you very much, and we hope you are prepared. Let's see what you have, please. God bless you.
Okay.
While group 2 is trying to do that, I think group 3 should be preparing. Please, once we call on you, immediately just share your screen. If you need to turn on your camera, just turn on your camera and then you proceed to sharing screen. We do not have a lot of time to use here. Thank you.
Mr. Lucky, are you here?
Yes. Can I share my screen?
Yeah, please, you can share your screen.
Yeah,
You
I'm
can start.
I'm trying to share my screen, but the thing is not working. I don't know if it's from my side. I don't know if you can hear me.
Yeah, we can
Yes,
hear you.
we can hear you.
Yes, I'm trying to share my screen. I don't. Okay. I don't know if you can see my. Hello, can you see my screen?
Yes, I've seen it.
Okay, let me open the slide. Okay, good evening, everyone. Hello, good evening.
Can
Good
you hear you? Good
evening.
evening.
Yes, good evening, Mr. Lucky.
Yes, and then I hope you can see the screen too.
Yes, we can.
All right, thank you very much. So today we'll be presenting our Group 2 project for the ethical hacking track, and our topic is the WPA and WPA2 handshake analysis and password recovery. So this is a concise technical audit and demonstration focused on understanding the vulnerabilities in WPA2 personnel and the importance of strong network security. So our objective was straightforward. We had to capture a Wi-Fi, WPA and WPA2 handshake, verify its integrity, and perform an offline dictionary attack to recover the preferred key or PSK. Now, let's think of a Wi-Fi network as a private clubhouse. To get into the clubhouse, you need to know the secret knock, which in this case is the Wi-Fi password. Our project simulated the role of an outsider trying to discover that secret knock. We focus on a demonstration network with the ESID 30 and BSS ID shown here, a common test case for the aircraft NG repository. Using specialized tools, we passively listen to the wireless traffic, that's the conversation happening in the ear, and then we capture the critical moment when a legitimate device connected to Teddy. That connection process includes a specific four-way exchange of information called the handshake, exactly like the recording someone performed when he's trying to listen to the secret knock. So our primary tools were the non-crack NG, aircraft NG suites for capture verification and cracking, and the Wireshark for deep packet analysis. So moving on to the initial analysis and file verification. So just like a detective must first confirm that the recording of someone performing the secret knock is genuine, untempered, and then complete before trying to decode what the knock actually is about. We had to validate our captured recording of the Wi-Fi connection. We confirmed the file is a valid pickup capture containing legitimate 802.11 wireless traffic by carefully inspecting the packet contents, much like zooming in the audio waveform of the secret knock. Using Wireshark and aircraft, we identified all the essential elements for a successful connection for the four-way handshake exchange. So the tools ran integrity checks and then we confirmed one valid handshake was present for the Teddy network. The evidence was sound, a genuine, complete recording of a legitimate device knocking and being granted entry to the clubhouse. Now, this is a screenshot showing the packet capture of a Wi-Fi four-way handshake, typically using WPA and WPA2 authentication. This verification step is non-negotiable. Without a clean, full handshake recording, any attempt to guess the secret knock will be pointless in this particular project. Now, let's walk through the recovery process. That's the main event, trying to figure out the actual secret knock from our recording of it being performed. Now, imagine you have a perfect audio recording of someone doing the secret knock to enter the clubhouse, but you don't know the pattern itself. You only know the sound it makes when it works. What could you do? You could methodically try every possible knock variations you can think of, comparing each attempt to the recording until one matches perfectly. That's exactly what we did, but with the computer acting as a tireless automated knock guesser. We selected large word lists of potential passwords, primarily the famous RockUTXT, which contains about 40 million real-world commonly used password leaked from past breaches like let's say password 123, pet names, food words, or simple phrases people actually use. So we then ran a dictionary attack using aircraft NG like a very dedicated person armed with a massive books of common knocks for each candidate password from the list. The tools derive the pairwise master key, that's the PMK, essentially computing with the correct secret knock sound should be for the password, and then it checks if it matches the message integrity code, that's the MIC, embedded in our captured handshake recording. If the derived PMK produce the exact same MIC as the one in the handshake, we have found the right knock, the password that opens the clubhouse door. This is an offline process completely. Once we have the handshake recording, we can take it away and guess as fast as our computer allows without ever needing to interact with the real network again. So here are the results. So here are the results. The recovered PS key for the network Teddy was Biscuit. We verified this key using both aircraft NG and we verified using aircraft NG. The time to crack was minimal, around 29 seconds. That means it didn't even use even half of the words contained in the dictionary. So it will bring us to the core of our research. We are going to look at the security audit, and then from here my colleague is going to continue. Thank you.
Okay. Thank you, Mr. Lucky. So
Yes.
the security audit report. Please continue sharing this slide, please. So as of March 1st, 2026, we confirmed that the target files contained valid WP and check traffic. This file is actually an official reference sample from aircraft NG project we use for tool validation. Think of it like a security camera recording someone entering a code into a keypad. If the system is old, an attacker can take that recording home and study the hand movement to figure out the code without ever being seen at the building. Then we go to next slide, the password recovery and methodology. We ran aircraft NG using the ROC U-test word list to match the PSK derived MIC from the captured frame. The passphrase was successfully recovered as Biscuit. It was found in 29 seconds after testing roughly 67,321 keys. Using a short 8-letter word like Biscuit is like using a common master key that comes with a cheap padlock because the word is so common and very short. If a computer can try it, then 1,000 others can try it, and then almost instantly until it clicks. So we talk about the risk mitigation and recommendation. To defend against this type of attack, users must replace weak password with high entropy passphrase of 16 to 25 plus characters. We also strongly recommend WPA3 personal, that is SAE. A short password is like just a standard door lock, but a high entropy passphrase is a bank vault door. Even if an attacker has the right tools, it would take them years to get through a vault, making the effort infeasible. Then WPA2 versus WPA3. The fundamental difference is how they handle guessing. WPA2 allows passive capture, meaning an attacker records you once and guesses offline forever, while WPA3 requires active interaction for every guess. WPA2 is like a thief taking photo of your key and making 10,000 copies in their home. WPA3 is like a smart lock that only gives you like 3 tries before it shuts down the system entirely, preventing the thief from ever practicing. So in conclusion, WPA2 network remains highly vulnerable if we use low entropy passwords like my colleagues say, password 123, our pet's name or our surname or any other weak password. Moving to WPA3 or using complex passphrases effectively renders these automated guessing attacks impossible. Thank you all for listening.
Okay, thank you very much. We'll now call on our lead mentor to give his review. Mr. Victor, you there,
Okay.
sir?
Well done, guys. That was a great presentation. Ostus, did they stick to the time? Like, I hope they didn't
Yes.
go beyond
I
time.
think they have like about 8 minutes more, sir.
Oh, okay, makes sense. So, okay, well done, guys. I think the presentation was great. I was just having a feeling that probably at some point in time you guys are reading the presentation. I don't know, but that was how I felt. So I just have a few questions. Can somebody just walk me through the process of cloning down to like I want to know how you guys managed to clone and then how you guys managed to get like the file you used, for the entire process or for the entire thing. So I just want to know, like, maybe somebody should walk me through, like, what are the commands you guys ran that gave you guys what exactly you guys were looking for? Anyone? You don't need to maybe go to Wireshark, like, just the process of cloning down to the process of, like, getting the file. Anyone?
Hello.
Yeah, hi.
Okay, I'm Enoch Fanu. So for this question, I can say to download the file from the GitHub link, we use wget command in Kali Linux.
Okay. So wget command, yeah, I'm listening. Is that all?
Yes,
Okay. So
and before
please pardon Enoch. Enoch is not he's not an English speaking person, like, first language. I think he's from French or something. He speaks French, more than he speaks English. So please pardon him. Yeah. So okay, Enoch, thank you so much. I've heard that. Okay, so aside from Haircrack NG that you guys use, could there be any other tools that you think you guys could have used to make the work maybe achievable? And
Yes, sir.
Loki as well mentioned that you guys verified the password using a crack NG. So I want to know how the password verification happened. How did you know that this exactly is the password? Because at some point in time you mentioned that you got the password, then later on you verified the password. So for the password verification, how did that happen?
Yes, sir. So I'm going to answer the first question you asked, which is which other tools can be used apart from the
Okay.
ECAC NG. Yes, sir. So we could actually use hashcards to do that because a hashcard is even more faster than ECAC NG. Let's say if ECAC NG is going to crack it in like 29 seconds, then hashcards could be able to do it in less than 29 seconds. Let's say 7 to 10 seconds.
Okay. To the next question.
Sir, please can you repeat the question?
yes.
Okay, I asked about the password verification. How did you guys verify that this is the password? Lucky mentioned that you guys got the password and then you used Crack Engine to verify. So I was wondering, like, how did the verification happen?
Okay, when we capture the handshake, verify that it has handshaking Wireshark, then we use a crack along with a dictionary attack that is word list. So aircrack like tests every word in the list against the captured handshake. Then it just keeps on running until it confirms that password. So once it confirms that password, it just like stop and bring out key found. So that's as we verify that
Okay,
that
so
was the
so so
password.
you guys are only getting the password, the correct password, nothing like you guys are verifying afterwards. Because I just wanted to confirm, yeah, I wanted to confirm the words of Lucky, and that's why I'm asking that. You guys said you got the password, and after getting the password, you verified. So that's why I was trying to, ask that. But it's not a problem, do you guys? It's not a problem. So you guys already did pretty well. Okay, thank you so much, guys. There's a question I wanted to ask
Please.
about. It eluded my mind already. So maybe we can move to the next thing.
Okay, so group one, are you guys ready now? Group one, are you guys ready now?
Yes, yes, we are ready. We are ready.
Thank you very much. So the floor is yours.
All right. Good evening, everyone. My name is Akidoyi Oluwayemi. I am representing Group A, and my team member name are Michael, David, Jeff, and Sam. In this project, we simulate a security audit of an internal employee portal to identify potential access control vulnerability using the Portugal Web Security Academic Lab. Many organizations use internal employee portal to allow staff to access sensitive information such as pay tab, personal records, and internal resources. However, if access control mechanisms are not
We can't
properly
see your screen again. We can't see your screen again.
oh, all right, next slide, please. All right, I'm continuing. In this project, we examine how such vulnerability occur and demonstrated how they can be exploited and mitigated. The objective of this project was to stimulate an ethical hacking engagement by identifying access control vulnerability, demonstrating how they can be exploited, and analyzing the security impact and recommending active remediation strategies. To carry out this security assessment, we follow a structured ethical hacking methodology. Firstly, we perform a reconnaissance to observe how the application behaves when users are logging and log out. We then use a botnet proxy to intercept HTTP requests and analyze parameters such as user ID that may control access to sensitive resources. Next, we also modify the parameters to test whether the application properly enforce authorization control. And finally, we documented our findings with screenshots and proposed remediation strategies to address this identified vulnerability. With this methodology established, my colleague will now walk us through through the lab A, when they demonstrated the first access control vulnerability and the findings we discover. So, over to you.
Um, Good evening. So this lab demonstrates a broken access control vulnerability where a web application uses a user-controlled parameter to determine which user data is displayed. Attackers can manipulate this parameter to access other users' information, although the application attempts to redirect unauthorized users, but sensitive data is still leaked in the response. So after logging in as winner, sorry, please, previous page. After logging in as winner, we access the My Account page, which displays account information, including the user's API key. At this stage, we enable interception in Bob Suite to observe the HTTP requests sent to the server. The applications identify user through the ID parameter in the URL. Since this parameter is controlled by the client, it creates a potential vulnerability. We then send this request to Bob repeater to modify it. Please, next slide. We change the user from Werner to Carlos. The application attempts to block access by returning a 302 redirect to login page, indicating unauthorized access. Even though the server attempts to prevent access, it fails to remove sensitive information from the response. As a result, attackers can still see Carlos' API key in the response body. Please, next slide. Next slide. So this is the API key. This vulnerability demonstrates how improper access control can expose sensitive information. Poor validations, secure coding practice, and strict authorization checks can prevent these types of attacks. So I'll be handing it over to my colleagues to talk about the Lab B and how it works.
Okay, thank you, Jeff, for giving me the floor.
All right.
Can you
Hello,
Hello,
good
can
evening,
you
sir.
hear me?
Yeah.
Yes, we can hear you.
Okay, thank you very much. So I just want to give you an overview of what Lab
Yes.
B or
Good
pardon?
evening. I'm Alan Michael from.
Hello, Michael. Can you please mute yourself? Hello, Michael. Please mute yourself.
Is that my and
Okay.
I okay?
Oh, he's the one presenting. Okay, Gibbs, I think
Yeah.
you should help us mute yourself.
Okay, sorry.
Hello, Michael. You can proceed then. Who is presenting? Is it Gibbs or Alayo?
Hello,
It's
Mike.
All
Are
Alayo.
right.
you?
Thank you so much, sir.
Yeah, you can proceed. We can hear you. You can proceed. I think you're cracking. You're breaking so bad. The voice is really cracking. Like,
Good evening, everyone. So now I'll proceed with.
sorry, am I the one not hearing him, or is audible enough?
No, his voice is cracking, sir. His voice is cracking.
Hello, Michael. Can you hear us? Can you please take a pause? Can you hear us? Can somebody just, alert him, maybe on the
From where
group or in his DM, so that he can be aware that we are not hearing him.
Yes, I'm on. And so I'll proceed to Lab B, which is so now we are.
Can someone else pick it up from there because of our time?
Okay, now can you pick it up from them, please? I think his network is bad.
Okay. Can you hear me?
Hello, sir.
Yeah, who was talking before?
Hello, sir. Can you hear me now, sir?
Yeah, it's
Hello,
better
sir.
now. It's better now, yeah.
All right. Thank you very much, sir. So I'll proceed with Lab B, which is step 1, which is the
Can
logging in
you
as
start from the
Werner.
beginning again, like from the beginning of your own presentation? We didn't
All
hear
right.
anything.
Please, the previous, go on, please. The previous slide. The previous slide, go on.
This is the previous.
No, I meant where you started, not where the entire team started. Where you started from. So
this
you can
this
just
this is it,
continue
sir.
from this lab overview.
All right, thank you very much, sir. I apologize for the network issue, sir. So now we are for the lab B, we'll proceed with what is the lab they're actually working on. What Swigger Web Security Academy. It is a free platform for practicing real web vulnerability in a safe, legal lab environment. Now, what exactly is the vulnerability that we're actually looking for? It is a broken access control, specifically an insecure direct object reference. The server trusts a user supply ID parameter to decide which account data to display with no server-side section. So now let's look at the attack flow. Like, what are the method of the attacking process? First and foremost is that we log in as a low privileged user, which is Wena, which happens to be the username, and Peter, which happens to be the password. Now intercept. Now after we've logged in as Wena and Peter for the password. Now we turn on the Bob suit, we intercept the get / my account ID Wena in Bob. Then after that we change the ID from Wena to administrator. Then when we do that, we definitely see the admin playtest password leak in response. Then we log in as administrator, we delete user Carlos, and then the lapse of next slide. So now in the next slide, we will actually be logging in as the first step. So now we see this next slide, which is my account. Now we have my account. If you look up, we see that the lab is currently showing not solved. That is, we've not done it. So we log in as the username, which is Wena, that was given to us, and the password, which is Peter, we input it. So now what is happening here? The lab provides us with a low privilege login, Wena username and Peter password. Then we visit the lab URL and log in normally as Wena. Then the lab status is showing us not solved, which is our goal is to change that. Next slide. Next slide, please. So the next slide we actually show us. All right, thank you. So now currently, when we are logging in as Wena as the low user privilege account, so we already turned on our Bob suite. We've turned on the intercept. So immediately we are logging in. Bob suite is actually capturing the response. Is capturing it. So when we sent it, the previous slide, it's not this. So when we send the login details, Bob Suite actually captured it. Then if we look at the Bob Suite response, we will see that in row 23, we can see the get my ID. All right, thank you. If you look at row 53, we will see get my account ID Wena, which we clicked on it. Immediately we clicked on it, it will bring us a response and a request information. So in the response and request, if you look at the request, we will see that there are some HTML code that was written there. That is where we will find the username for the administrator and other users leaked in that place. So what do? We copy the response. So next slide. So we copy this response. We right click on your system and you forward the response. You forward it to repeater. So it is on repeater. The question says that we have to change the user Wena to administrator. Next slide. All right, so this is our repeater now. So we can see that on the repeater, if you look at the get / my account ID, we have the administrator there because we actually changed it from Wena to administrator. And immediately we change it from Wena to administrator, we click on send. When we send it there, it will bring out a request. And in that request, we will find out the administrator username, the administrator password, and the rest. So now, when we do that and we copy the username and the password, we put it on login. So we logged in. So we log in as an admin panel. When we log in, the next thing we see the users that we see the user Wena, like I've seen on the page, and user Carlos, just as we're seeing it on the page. So the admin panel is now accessible in the nav proof. We are logging as an administrator. Wena and Carlos, we need to delete Carlos to complete. Next slide. Next slide. So we need to carry out the task by deleting user Carlos. Now we successfully deleted user Carlos, and we can see that the lab, if you look at the upper top of the screen, we see that it is showing lab solved. See that it's showing lab solved. That is, we successfully deleted the user Carlos as an administration. Thank you. I want over for my next presenter.
All right. Good evening, everyone. Can everyone hear me?
Yeah, we can hear
Can
you.
everyone hear me? All right. Okay. So good evening, everyone. My name is David. Okay. So thanks to my past presenter. So they have laid the groundwork for me. So this my own presentation is basically the same iteration of broken access control, but this time around we are going to intercept. We're going to intercept a request, a chat request between myself and an LLM. So from what you see here right now, this is just a simple chat. So there's an LLM called Helpline, and you were just texting like a random LLM. And while he was texting, basically when you go into the login page and then you click on live chat and you actually live chat with it. So while I was texting, while we were texting this LLM, behind the scenes we had bots running to intercept every request. Sam, please next slide. Okay, so now what you see is after chatting with the LLM, I went ahead to download the view transcript. I went ahead to download the transcript. So basically, why I was trying to download the transcript is the idea of this exercise is to be able to manipulate my own chat history, to be able to get the chat history of Carlos. So the end goal of what we are trying to do here was to get the password of Carlos, and that can be gotten through Carlos' chat history. So what you're seeing here is after texting from the LLM, you view the transcript, which you download it. And now the next slide is going to show what happened in Bob. So this being the next slide right here. As you can see from the slide, you can anyone hear me? Can everyone hear me? Hello?
We can
We
hear
can
you. We
hear
can
you. They
hear
are just
you.
telling you that you
Okay.
have 2 minutes more. Go ahead. Yeah.
Okay. So just to round it up. So we'll send this request to the repeater, right? When you send it to the repeater, so Sammy, next slide, please. When after you send to the repeater, you modify it by changing. So from the last slide, I don't want to go to the last slide, but from the last slide, my own message was 2.txt. Now that is my chat history. Now when I change it from 2 to 1, it gets to Carlos' chat history, and then the password is there. So and then I've gotten it. So please Sam, the next slide. So after I've gotten the password, I log in using Carlos and the password that's gotten. So Carlos, the next slide, please. Sam, the next slide. Now just by simply logging, so I basically got to the login for Carlos by just intercepting my own request, then manipulating it in order to get the chat history of Carlos, and this can be avoided by using a UUID. So instead of using a simple value like 1 that can just be guessed, you are supposed to use UUID, something that is not predictable. So thank you everyone.
All right, thank you. In conclusion, this project has shown the importance of implementing strong access control mechanism in the web application. One key lesson we learned that development you never trust user input without a proper validation and authorization check. We also appreciate our colleague who in handling the screen sharing during the demonstration. Thank you for your time and attention. We welcome question now.
Okay, thank you so much. All right. Also, I think I can give feedback with questions. Like I can do the both now, right?
Yes, please, it's
Okay.
your floors.
Okay. All right. Thank you. So for your slides, I don't know where you guys got the slides from. The slides was not so good, most especially for the first presentation. It looks as if I'm not saying that was what happened. So, but it looks as though you guys gave ChatGPT a prompt to generate some slides for you, and then you guys now probably developed that, or you now worked on that, to come up with this. I feel the slides can be way, way better, right? And then for transitions as well, most especially in between slides to slides, I think it could have been better, probably due to maybe some lags, maybe due to the internet. You guys weren't able to flow very well. That's another challenge I saw there. Probably you guys could have maybe do a dry run prior to coming to this call. Maybe that could have helped you guys so that you would have known that so person is not going to have a good lab, good network, and this is how the transition is going to look like. Maybe you guys did that. Probably the network just wanted to, do his own when you were actually presenting. So that's another thing. Also, I think there was a delay. You guys had to be the first team to present. Your team were not on the call, and by the time you guys would come back again, you still struggle to share the screen, move from from the first slide to another slide. It was a problem. So I felt you guys could do you can do better in that area. So for the I just want you guys have like four sub projects in the entire project that you guys worked on. So for each of them, I meant the labs now. For each of them, what can you say is the lesson you picked from each of them? And what would you recommend the clients to do if you are doing that in real life, right? Say for instance, the one David presented, a chart with an LLM. You you are giving your probably you were chatting with LLM. Maybe you were fixing some issues with probably you're developing something and you're fixing some issues or you're encountering some issues and you're trying to fix those issues and unknowingly you had fed the errors, maybe the error is having some information you shouldn't have disclosed. You fed that into the LLM, or probably when the LLM was asking to see your code or something, instead of you to probably separate your API keys or some of your password or login details into an environment variable, you probably just maybe you had coding that in your code and unknowingly you copied and pasted that into the LLM as well. So in all of those cases, and in the cases of each of the labs that you presented, what do you think is the life lesson you got from that, and what would you recommend a client you are doing that for, or you are auditing or trying to pen test for? What would you recommend that client to do?
Okay.
All
To
right.
answer. Okay, so I'll answer from my own perspective from the chatting LLM. So basically, the issue with texting the LLM is so this could be resolved by something called a UUID, right? So from my own chat, which is a UU, sorry, from my own chats, you can actually see that my own history was just saved by UU, by the, sorry, was just saved with a one, right? Was just saved with a two rather. So basically, as an attacker, is actually a no-brainer to just know that okay, the past user kind of is just easily one, and then that's basically you can just get the login details. So how a developer or what to advise the client is to avoid this type of problem, they need to implement a UUID. So UUID is basically instead of that one, you will see is like a combination. So it's basically like a 1 to 8 bit label used to uniquely identify information in computer systems. So basically, um it's just something that you put instead of that one. If you implement a UUID, and anyone reads that, they won't be able to even understand or to even like manipulate that. So it is that easy to manipulate just because of the request. Because of all it's just a simple request that you can download and you can see through. So if I was to recommend this to a client, I would just basically say, okay, so you need to implement a UUID to avoid this, which is basically a universal unique identifier.
Okay. So, don't you think, that's a great one, from the technical perspective. But don't you think there should be some sort of user awareness or staff training on how to use LLMs? The LLM could be a system that gives you almost answers. I mean, I can give you answers to almost all your questions, but there are things you can feed into it. Because even if you're using a UUID, if somebody is very good at prompt engineering, they can prompt inject the LLM, right? There's something called prompt injection, and then from there, they could manipulate the LLM to probably give out some information that it has previously been given to it prior to that time. So that's another thing I was really expecting to hear. There are details you don't give to LLMs, most especially if they are not local LLMs. Local LLMs are LLMs that you are deploying for just your own usage, and you guys have total control of the data and everything. Even if it's a local LLM, there are things you still must not do, such as feeding your API keys, passwords, and sensitive details into the LLM. So it can be very, very disastrous. All right, thank you for that. Does anyone wants to give it a try again? Maybe for other labs. So if you are getting no response, then we can move to team three.
All right. I will not try as much as possible to say that according to what we demonstrated in Lab B, you know that that lab is we demonstrate a vulnerability called user ID control by we create a parameter with the password disclosure. So and I think that when we report login and when can you hear me?
Correct. You can proceed. We can hear you.
Okay. So I think the recommendation me I am going to say for the client if they are auditing their system is that like you usually tell us that you never create user input. You must try as much as possible to import a free server side and authorization check is really, really important. Like you always tell us. And for a client, I think if you implement a strong access control policy also. They can also secure the password handling and conducting a regular baby security assessment to protect their sensitive data. Thank you, sir.
Okay, thank you so much for that. Yeah, group three.
All right, so thank you very much for the presentation. We are waiting for group three. Group three, are you there?
Yes, sir, we're here.
God bless you, group three. Let's hear from you, please. Thank you very much.
So, let me share my screen first. Yes, this. Can you see my screen? Right, that is.
Yeah.
Good evening, everyone. Am I audible? Hello, am I audible?
Yes, we can hear you.
Go ahead.
Yeah.
Okay. So this is group three, and our project was on SQLI vulnerability on DVWA at medium level. And in this group, we are two, which I am Bakel Gideon, and with me is Rebecca Nati. So moving on to the introductions, what is DVWA? DVWA is Damn Vulnerable Websites web application and is designed for learners to practice and understand web security vulnerabilities, including SQLI injection, XSS, brute forcing, and IDOR, yeah, IDOS, indirect object and the rest here. So in a controlled environment that simulates reward scenarios. So the main purpose of DVWA is to create secured and this secured simulate reward simulated space where cybersecurity learners or anyone that is interested in learning web security and web security vulnerabilities can come in and go through all the security vulnerabilities, go through the test and the hands-on practice of these vulnerabilities. So setting up DVWA. There are different ways to set up DVWA. You can set it up using a virtual machine. You can set it up on your local host as on your main machine, or you can set it up using Docker. So I set it up using Docker for security reasons because to give it that isolated environment. To set up your DVWA using Docker. On my terminal, I ran docker run dash dash rm, which is to remove and destroy the container and any associated files or folders related to that container immediately I exit. And then there's dash IT, which is to enable interactive mode, and then dash P, which is to state the port, and then vulnerable slash web dash DVWA, which is the directory to DVWA on Docker website. So I could access my application via the local Docker local host, which is http://172.17.0.2. So understanding SQLi. So we need to understand structured query language injection vulnerability. So that's the full meaning of SQL, structured query language. And then this is a critical vulnerability that allows attackers to manipulate SQL queries, potentially leading to unauthorized access, data exposure, and significantly security breach in web applications. So it's a very dangerous vulnerability, which just involves the attacker to get an entry point on a website. With this entry point, the attacker can manipulate the website to get information from the database that is linked to this website by putting up queries in SQLi. So they try to bypass the usual query text field, which will lead them into merging their query to a merging their query to a normal SQL command, which will in turn give them this output of what is in the database. So moving on, we have to compare the security level in both DVWA low security and medium security. And in comparison, the low security lacks input validation, but the medium security implements basic sanitization through escaping. So that is the difference between the low level and the medium level in DVWA. So here is the source code for both. This is not the full source code, but this is where the difference lies. In the low security injection source code, you can see at the ID, the variable ID, the value is request into square brackets ID. But then in the medium injection source, though they are not using post, they are not using request, they are using post. The next line has another variable whereby they try to escape strings. So they try escaping the usual string imputation of strings and to avoid directly imputing commands as your initial query. So in DVWA medium difficulty, the website still builds the SQL query by joining user input directly into the SQL statement. Even if it tries to clean the input first, the user's text still becomes part of the actual SQL command. So when you bypass it, which I will show in the next slide, your text is still going to be part of the user command, and the way to bypass it is simple. So escaping input does not guarantee security. Despite basic sanitization, attackers can still exploit logical operators to manipulate queries, exposing vulnerabilities that lead to unauthorized database access and database breach. So In the security vulnerability now, this is how the medium text field is. There was no text field for the medium level. There was just the drop down menu, which was what we were going to use. This output here was output from a union command, union statement, SQL statement. So I just used union with the normal SQL variable. And this union here was to merge the basic number three, the basic input, which was our number three. And that is our means of the escaping the security measure that was utilized in this medium level security. So the number three, which is a number, you can use number two, you can use the number one, just use any number and you'll be able to escape it. Use it together with a SQL statement, any SQL statement, as far as you have a kind of picture or structure of how the database should be, use it with a SQL statement to draw your required data out. And with this, I was able to draw the first name, the username, the password, and that is everything that is out here. So the entry point for the SQLI, as you can see in this image here, this is our request from Bob Suite. And at the last line, we have this thing, the SQL injection there. The ID, as was also seen in the previous output and the previous web page, you see the ID is number two, and that is that number that was there as the text field, sorry, as the drop down menu. So in Bob Suite, we just capture the request, leaving the number that was used. We just add our statements at the back, or one equal one, and then we get a list of all. Okay, yeah, this is the same payload, or one equal one, and then we submit it. We get this a list of all the users, as far as we keep our initial number two stable. It could be any number, like I said before. The main purpose is just to bypass the escape the basic sanitization that was used in the medium level security source code. That's why we use the number. If it was a letter we used, it won't work. If it was a symbol we used, it won't work. It will output an error. So using the number is the way to actually merge our payload to the request. So using the advanced payload, the other initial payload was just a basic payload, and then this one, an advanced payload, was the union injection technique. Though there are still more techniques that I would have tried out, but this allows attackers to retrieve sensitive data by combining results from multiple queries, potentially exposing user info such as username, password, like we did and you saw in the previous output. So imagine our um, database looks something like this. Though this is not how DVWA database look. If it looks something like this, we will definitely be able to get our output when we have our picture of, okay, this is how our database is, and then we pull up um the payload as this, as seen in this ID, three union selects and the remaining SQL statements with the commenting at the end, dash dash hyphen hyphen. With that, we comment out the remaining aspect of the SQL statement and they run only this, which retrieves our information. So understanding filter bypasses. Medium level filter may escape both, but they fail to secure against logic operators. Attackers can exploit this weakness, alter query logic, and gain unauthorized access to sensitive data, like seen in the walkthrough samples that were up there that I showed previously. That is what the escape quotes, the medium level filter only does. It will only escape quotes.
Can you guys still hear
But it
Baker?
won't
I can't hear him again.
union to merge this remaining query SQL statement to it. So moving on, understanding injection, understanding SQL injection analogy. The bank teller executes requests exactly as stated, just like an insecure application process inputs. Proper verification prevents unauthorized access, ensuring that only legitimate requests are fulfilled, maintaining security. So how this actually works is, okay, the bank teller executes a request as stated. He executes his request, and then in an insecure application like the DVWA, it doesn't check this query that was used. And since this query was not well properly sanitized, there was not some security implementations against SQLI. It goes unauthorized. You gain unauthorized access, which gives the bank teller inappropriate access to certain things. But in a case where there's proper verification, this prevents unauthorized access, ensures that only legitimate requests are fulfilled, and it maintains the security of the websites in use. So there is the SQL injection. It helps with it succeeds because user input is directly mixed with SQL queries, allows attackers to manipulate the database. These flaws arise from a lack of proper inputs, validation, and parameterization in coding practices. So the user input is directly embedded with the SQL queries, which makes this SQL, which make SQLI possible. So I'll be handing it over to Rebecca from here.
How are we going to implement this?
All right, thank you very much.
All right.
All right, thank you very much. So I'll be continuing from here. So we are going to look at common developer mistakes. So earlier we saw how SQL injection works, how attackers can trick database by mixing their input with SQL commands. But let's look at the bigger question. Why do all these vulnerabilities still exist in real systems? Well, it's usually, we've mapped out that from research and from studies, it's mostly because of developer mistakes. As you can see, the first one is lack of input validation. Remember earlier that in the early slides, where the ID parameter was vulnerable. Well, that happened because the system didn't check if the input was really a number. So the second is cryptography. So we saw the password hashes like the 54 DC from the earlier side. And in the union injection example, that's MD5. And as we can see, it was an outdated hashing method that can be cracked easily. So looking at the third, which is the insecure code dependencies. Developers often use libraries without checking if they are safe, which introduces more hidden vulnerabilities. So the fourth, which is the misconfigured systems. So just like the DVWA runs with intentionally weak systems. So the thing is, real systems sometimes leave default configurations open. So this is one of the common. All right. So wrapping up, we have the weak access control, we have the improper error handling, sensitive data exposure, insufficient logging, and all that. So we are moving to the proper remediation with prepared statement. So now earlier we saw the unsafe concatenation versus the safe parameter binding, and the fix is actually prepared statement. So instead of building a query by gluing user input directly, the developer can actually create a safe template first, then the user's data is later inserted separately. So you can actually think of it like filling out an exam paper. The questions are fixed, right? You can only write in the blanks. You can't change the questions themselves, but actually you can. So that's actually how the prepare statement can protect database. So the next is
Sorry. So the next thing is advantages of prepared statement. So as we can see, prepared statement have clear advantages. That is one, completely block SQL injection. Then they make life easier for developers. Then they can actually support almost every they they are supported almost everywhere, like MySQL, PostSQL, then Java, then Python, then PHP. So they are not just secure, actually, they are practical. So the next slide. So we can actually look at best practice for prevention. Um, the next slide. Yes, we can actually look at best practice for prevention. And so beyond prepare statement, developers can actually follow these practices. They can also always validate user inputs. They can limit database privileges. If the app only needs to read data, they shouldn't give admin rights. They can hide detailed error messages, and also they can regularly test applications with tools like DVW, OAuth, ZAP, or PEP Suite. That are the same tools we saw listed in the resource slides. So the next slide. So my takeaway is that SQL injection isn't some super advanced hack actually. It just using to it's just exploiting poor coding practice, and this has really helped prevent all these vulnerabilities. So the next slide. Okay. The summary of our presentation is actually to know that SQL injection is one of the most common web vulnerabilities, and it happens when user input is directly inserted into SQL queries. And we have also learned that attackers can use it to steal usernames, passwords, and other confidential data. And we have also learned that with all this, there are more secure coding practices like prepare statement and other things that developers can actually learn to stop attackers from attacking their web. So thank you very much. So I think our listing of our next slide, which is the last slide, which is listing of the learning and the resources. So if you want to practice more, okay, there are great tools out there, and we have the DVWA, sorry. It helps you to safely try out attacks and defenses in controlled environments. Okay, we have the OAPS ZAP. It also helps test applications for vulnerabilities. And we have tools like SQL Map, PEP Suite, and NMAP. They're all listed in this slide and are all used by professionals to find weaknesses. So thank you very much for this presentation, and we are open for any questions. Thank you.
You're welcome. Thank you very much. Mr. Victor, if you are there, the floor is yours.
Okay. Damnari Ogunshaki, in case you never intended to turn on your camera is on. So, nice presentation, but I'm wondering how you guys are two and you spent more time compared to those who have more than two persons, presented for them. But it's okay. What I will just tell you guys that you spent a lot of time on introduction, introducing the project itself to us, explaining SQL injection and all of that. All those time, we just assume we know SQL injection. You don't need to give us all of that, right? And yeah, I felt you could just go straight into the presentation and the work you did. Like, what did you do? What exactly did you do? Yeah, and then you go straight to that. Also, I felt at some point in time that probably you guys got some of the screenshots. I don't know because I wasn't seeing. I don't know. Maybe the way you guys cropped stuff, you just cropped the request part of things, and you were not really showing. If you look at the way group two or team two presented theirs, they are highlighted, where the payload is, the canaries, what they are modifying, they explicitly stated all of those things, or identified, or should I say ringed out, they ringed out, all of those things in their presentation or in the screenshots they added to their slide deck. But I wasn't seeing that here. So all I was just seeing is just like the box that contains the request. You didn't really take us through the entire experience. Yeah, and you did more of explanation on SQL injector. At some point, I wanted to ask you that, do you guys want to teach or you want to present your project? Because towards the end, you were still telling us where we can get resources to learn SQL injection, telling us, do you get what I'm trying to? So go straight to the project. This is the project we did, and then you take me through, the entire thing. Oh, this thing is a drop down, and then because we have because we cannot impute something directly. That is why we are using what's the name, Bob Suite, to capture the request. We turned on our intercepts to do that. I didn't hear all of that. So we turn on our intercept to do that. We capture the request, and then once we capture the request, we then modify that request to really fit or support whatever we wanted to do. And once we've done that, we've changed, the what's it called? The ID there, like the payload, like if you look at the last thing on that request. So where you're having ID equals to 1, so you are changing it maybe to 1 or 1 equals 1, something like that. And I was expecting an explanation on, okay, if you're doing this on the web, you're going to be using quotation marks. We are not using quotation mark here, maybe because Bobsu does not support some of those characters. You know, things you did, what you did is what the presentation is all about. And that was why it was giving me this concern. And it was, style sound, your camera is on. Is it style or cipher sound, something, or cipher sound? So I was probably thinking maybe you guys just went online, got a screenshot, and then you came, to just dump that inside your slide, and you just cropped things out so that Mr. Victor will not know this thing, and then you just dumped it inside your slide, and you just came to present it. That's my feeling. I'm not gonna lie to you, because the presentation is not really, really, yeah. So, and I felt that you guys are too, and you guys will be able to cooperate more and be able to do your things neatly, and your presentation should be top notch as well. But in general, I would say you guys did well. You can just, it can always get better. Do you get what I'm trying to say? So next time when you have the opportunity to present, that is how you should go. You should handle it. Go straight to the point. What did you do? You are not coming here to teach. You are coming here to present to us your project. What did you do on SQL injection? And the beauty of everything you did, was not shown. It wasn't shown. You were just giving us explanations, and at some point that it became so boring because we weren't even learning anything. We wanted to see the exciting stuff that you guys did and the result you guys came up with, but we weren't really seeing that, right? So we're just seeing explanation and slide moving from one page to another. So I feel you guys can do better next time. All right, thank you so much, Bakel and Rebecca. All right, Austus.
Okay, thank you very much, sir. That was a wonderful review. Moving on, Group 4, are you there? If you can hear me, are you there?
Yes, sir.
Yes, we are.
God bless you. Okay, so the floor is yours, and we are hoping for the best from you.
Okay. Good evening, everyone. So my colleague Emmanuel will take it from here.
Can we have the slide, Chinasa?
Yeah.
All right. Good evening, everyone. And thank you for the opportunity to present this project. My name is Olanrewaju Okedele, and I'll be presenting this project on behalf of Group 4. The title is Secure Login Module And we developed this after identifying an authentication vulnerability during security testing. During the air assessment of the training application, we observed that the login functionality relied on dynamically constructed SQL queries that processes user input directly. This design exposed the system to SQL injection attacks, where an attacker could manipulate query logic to bypass authentication or extract sensitive data. The objective of this project was therefore to demonstrate how such a vulnerability can be mitigated by implementing secure authentication practices and safer database interaction techniques from the point of view of a junior security engineer and data backend developer. In this module, we redesigned the authentication logic to use parameterized queries, ensuring that user input is treated strictly as data rather than executable SQL code. This prevents attackers from altering the structure of database queries. In addition to preventing SQL injection, the module also introduces a more structured authentication flow that supports further hardening measures such as logging, rate limiting, and multi-factor authentication in future iterations. The goal of this project is not just to demonstrate an exploit and its fix, but to highlight how secure coding practices can significantly reduce the attack surface of authentication systems, which are often one of the most targeted components in modern web applications. In the next few slides, we'll walk through the vulnerability context, the secure implementation approach, the threats mitigated, and the recommended feature security improvements. Click. So we'll go over to vulnerability overview. The vulnerability overview. Chinasa, are you there? Please help with the, go over to the third slide. Okay. The original login system constructed SQL queries dynamically from the PHP source code on DVWA. The user input was directly embedded in database queries, which was used to escape using the MySQL _real_escape_string, which only works if the variable you are escaping is wrapped in single quotes inside your SQL query. And the risks that come with this kind of practice are possibility of SQL injection, authentication bypass, and unauthorized database access, which could also lead to the stealing of data and the rest of that. So let us see how the data was escaped. The next slide, please. From the source code, click. Can you expand this a bit? So from this code, from the third line, you see this is the PHP code from the source code on the DVWA. From the ID equals posts in quote, single quote ID, that was escaped using the ID equals MySQL _real_escape_string global, which translates with a comma and ID. All these are still considered as a string because the PHP treats inputs as strings and not integer or any other value. So all these still concatenate as strings, and the malicious attackers can take advantage of this to gain access, bypassing authentication security to get access to the database and get sensitive information from the database. The next slide shows us the attack demonstration. Click. Here is an example of the vulnerable query and its application. The query is executed as select first name last name from users where user ID equals ID quoted. So these malicious inputs that is imputed into this is 1 or 1 is equal to 1, which is a logical statement that will always return true when executed. So this is used to bypass the validation. And this is executed as query equals select first name, last name from users, where user ID equals 1 or 1 is equal to 1. So if the input is wrong, then in this case now, the logic 1 is equal to 1 returns true, which gives access. And this is a poor practice in security. The database returns unintended records. As you will see in the next slide, the vulnerability that comes with a SQL injection. Click. That injection was able to output the whole record of the users in the database. That is, you have the for ID 1 using 1, ID equals 1 or 1 is equal to 1. You're able to get the first name admin, surname admin, and the same ID 1 is equal to 1 or 1 is equal to 1. First name Gordon, surname Brown. Up to the last, which was ID 1 or 1 is equal to 1, that returns first name Bob, surname Smith. This comes with risk and impact for the database. And let us assess the risk now. Using the OWASP top 10 and the common vulnerability scoring system, this risk is, the severity is scored as I. That is how you see the red box there. The authentication, there was authentication bypass, there was unauthorized user access, and there was exposure of sensitive data and database manipulation. These were some of part of the things that we saw in the presentation of group 3. So this slide summarizes the security risk identified during testing. The vulnerability involves a SQL injection flaw in the authentication query, which could allow attackers to manipulate database queries through crafted inputs. The potential impact includes authentication bypass, unauthorized account access, and exposure of sensitive information stored in the database. Based on common web application risk classifications, such as those outlined in the OWASP top 10, this type of vulnerability is considered high severity because it directly affects authentication mechanisms. The implemented remediation replaces dynamic query construction with parameterized queries, ensuring that user input cannot modify SQL command logic. Next slide. So here we have the secure authentication architecture, the secure login flow. The user submits credentials. Input validation is performed on the credentials submitted. Parameterized query is executed, and the database verifies the stored data, and application returns authentication results. User input is treated as data, not executable SQL. The code we use to implement this is in the next slide. The preferred language, the preferred coding language that we used in this exercise is Python. And we import SQLite 3, import login, and from typing imports, which is optional, dictionary or any. Then we created log using login.basic config. File name is project4_security.log to take care of our logs. Level equals login.info. Then we define get_user.info user ID, which must be an integer. That is the parameterization now. Optional, it can be dictionary, string, or any. This surely retrieves user information using parameterized queries. It prevents SQL injection completely. Then we applied defense layers. The first defense layer applied is input validation. And the process is the conditional statement. If not, is instance. User ID, that's the parameters, user ID and integer, or user underscore ID is less than 1. Login.warning, output suspicious user ID attempts based on the parameter user ID to return none. Try with SQLite 3.connect with the parameters users underscore database.db as connection. This auto closes the connection. Then cursor equals connection.cursor. So if immediately this is executed, that auto closes the execution. There is no way any kind of injection can occur in that place. The second defense layer was parameterized query, which was the key protection. Our query was select first name, last name from users where ID equals question mark. That is the placeholder for the ID. And cursor.execute based on the parameters query, and the query is based on user ID as well. This is a very safe practice. Then for row equals cursor.fetch1. We are picking one at a time. No way to print more than one. If row, a conditional statement, login.info prints user info retrieved for ID, input the user ID. This returns ID, user ID, which is first name is row 0 index. And last name is row index 1. Else return none. This practice makes sure that if an attacker inputs a wrong information or value into the system, it is not going to reveal any sensitive information to them. It rather returns nothing. Then we have an exception, except SQLite 3.error as E, login.error returns or prints database error as E. This returns none. This step ensures that the program does not crash if wrong inputs are inputted into it, and it also secures the database information. We go over to the next slide. Comparing the vulnerable versus the secure implementation of codes. The vulnerable code was the PHP code, and the secure code was this Python code we just discussed. Excuse me. In the vulnerable version, the implementation of security was manual escaping. User input becomes part of SQL command, and the query looks like where ID equals ID, and there is no code to escape from. The other one that used the MySQL escape has been deprecated since PHP 5.5, so that is no longer in use. For the secure version, it was parameterized query that we used. And example is select and the rest of them where ID is equal to question mark, a placeholder for a definite answer. The security improvements were input validation, parameterized queries, security logging, and safe error handling. The
2
test
minutes more.
SQL injection.
2 minutes more.
Okay, thank you. So the security improvements implemented were key defensive layers implemented. That is the input validation, parameterized SQL queries, security event logging, controlled error handling, and this approach implements defense in depth. Lessons learned. This project highlighted several important security lessons. First, input filtering alone is not sufficient to prevent SQL injection. Secure query design using parameterized statements is required. Second, authentication systems are one of the most targeted components of web applications, which means small implementation flaws can have significant security implications. Third, applying secure coding practices during development greatly reduces the risk of vulnerabilities reaching production environments. Finally, security should be embedded throughout the development lifecycle, including design, implementation, testing, and review. That is CI/CD, continuous integration, continuous development. So what are the future security enhancements, recommended improvements? Multi-factor authentication, rate limiting on login attempts, centralized authentication logging, periodic security testing, integration of secure development lifecycle. Secure authentication is the foundation of application security. Small implementation details can create major vulnerabilities, which is why secure coding practice must be integrated into the development lifecycle. On this note, I want to thank you for giving me your audience.
Wow. Okay. Well done. Uh, okay, so we'll be waiting for our lead mentor to make his review. Thank you very much.
All right. Thank you so much, Lanrewaju. So sorry, are you the only guy in the team?
No, no, no. He's not the only one. No.
Oh, Chinasa, you're talking.
Yeah,
Okay, so
we're
Chinaza is
five.
saying he's not the only one, so definitely Chinaza is part of the team, correct?
Yeah, Chinaza was on the slide.
Okay.
We have
Okay.
five people in our group.
I'm actually wondering why you're the only one who presented, the entire thing. Okay. My feedback, great presentation. I felt it was a bit slow paced. That was one. Number two, it was having a lot of introduction. On the first slide, you spent about 1 minute there, if I'm not wrong. And a lot of explanations were done, and also, just the way I mentioned it to the previous team that presented, I really want to know, are you guys coming here to teach or to present what you have done? Because it's like you guys are the next generation set of teachers in cybersecurity, right? I was expecting to see purely how do I put it? Like a pure report on what you've done, like just the report of what you've done, and the report will just be in form of a presentation. Like you are presenting the report to me. It's just like I'm the management. You've done some findings, and you're telling me these are the things you've seen, and these are best ways to remediate. And you guys prefer, you provided I think a secure implementation code for MySQL, I mean for Python, because you showed the vulnerable one and then you showed the secure one, which I think makes sense. But I felt all of those things could have maybe been in form of a report normally. Also, I didn't see anything like Bob Sweet. Did you guys use Bob Sweet? If you didn't use Bob Sweet, did you guys use the DVWA at all? I never, I didn't see any interface. I didn't say, did you guys use anything like that?
Yes, sir. We did.
So why didn't I see the interface? I wasn't seeing any screenshots. You guys are just, telling me you're using one equals one, this and that. And probably you guys just tried maybe a single payload. So I don't know. Maybe you guys have some explanations to provide in that regard.
Okay, for the DVWA, we provided just one screenshot, maybe you were expecting more, but we provided just one, and that was
Let me send the screenshot again. Sorry.
okay. That was the screenshot of
The PhD.
the vulnerable PHP code.
Yeah, yeah. That is just the screenshot of vulnerable PHP. How did you guys bypass? How?
Okay.
I mean, no, you don't need to explain now. I wanted to see it on your slide and you walk me through it.
Yes, the code is there. The code is there. No, not this. Chinas are not this.
Which one?
The vulnerability.
As soon as that service is asking that which one, did you guys do this
Yes, the
thing
one
together?
for before risk impact assessment. Okay, immediately after this slide.
This one.
Yes.
Okay, this is a drop down. How did you bypass this? Definitely, you are capturing the request. Abi, am I wrong? You are capturing
No.
the request into Bob Suite, correct?
Yes.
Yes,
Yes. Yes.
Where is the screenshot of the Bob Suite? Where is the screenshot of the request? How did you modify the request?
Okay. Okay. Now I understand what you mean. Now I
Do you have
understand.
that?
You don't.
So
So how do I know this can be gotten? I can do a search on the internet now and I will see this thing. It can be gotten from anywhere.
yes, of course. But so the idea why we did not include that here is that our entire project is reference to the project of group three. So and they already did all that. So we just focused on the main point, which is the main um, thing that we were tasked to do, which is develop the secure code. And that is why we did not go in depth into
They
the.
themselves did not show it. Did they show it? We were both on Discord. Did they show it? They didn't. They didn't show it. You guys didn't show it too. So you see this the last two groups. I mean, well done. Like great work you guys have done. I celebrate you people, but I just feel that it can be better, right? It can really be better. So you guys should check group two. Aside from the fact that the first, maybe the first few slides that they presented were somehow, if you look at the progress like along the line, you're going to see the way they are pointing out and identifying different places on their screenshot. That is how it should be. That's how it should be. So I'm just saying one ID, one equals one. I didn't know the payload. I don't know what you guys are doing. Was it that you guys selected drop down and you selected one? If you selected one, it should only be showing and you click. If you selected one and you click submit, it should only be showing you the one for ID one, correct? So how did you get this? So you were
So
saying attack demonstration, you are putting everything on the slide, and your slide too can be better. The design is not so good. I'm so sorry. My feedback sometimes can be very harsh. Just take it and work on that because you guys are going into the real world, right? So the design can be way better, way better. In fact, if you guys got a template, maybe a very nice template on Google Slides, and then you played around that, I think it's going to give you a better result. So I just feel things can be better. You guys did your best, tried your best, but this doesn't really look like ethical hacking to me, to be honest. My expectation was that you guys are going to do, all of the labs that I gave to you guys, and you guys will come here and present everything. But today I was hearing from your representative that you guys wanted to pick, one project for one group, one project. So I was like, okay, fine. What's the essence of the 15 minutes you guys wanted to use? But I just let it slide. But now I was really expecting that since you guys are picking one project to present instead of the 30, then it should really be, so sound. It should show every necessary thing. Or when I was teaching you in class, was I obscuring some things? Maybe I would just say that this one is, I don't want to show you, and I would just jump to results, or I would just be using my mouth to explain things. I didn't do demos for you guys. So why aren't you guys showing me that? I feel it can be better, guys. It can really be better. So that's my feedback for you guys. Don't let it come as as discouragement to you. So let's encourage you, right? So you are going into reward already. One of the things you must know how to do in cybersecurity reporting in general is to know how to design slides. You must, because that is what you are going to be presenting to the management. You must, it is compulsory you know how to design slides. The slides for team 32 was nah. You guys, even team 2 was using, is it a black icon on a black, maybe on a black background. I was wondering how you guys were there to see that. So that's one of the things you guys should notice. Some of you guys came to GRC presentation. Look at their slides, right? Look at their slide. I think they all followed this, a kind of single pattern of slides and all. But the slide was really okay. For this, like, I'm expecting, oh, these are the number of vulnerabilities we detected. Like that should be like the introduction. Oh, we did this, or this is the scope of our engagement. Then you read down to us, then you walk us through what you did. Okay, we found this vulnerability. These are our findings. And for these findings, this one is serious according to the common vulnerability exposure. You state the ID. This is more serious. And at the end of the day, you show us how you were able to get those findings. Then you tell us maybe remediation processes, things we can do to fix those issues. Simple. If you can do that in 10 minutes, you're good. You're good. So I wasn't expecting you to come and teach me. I was expecting to come and present what you have done. But how do you prove to me that you've done something? It is to show me like screenshots. Because even when you're presenting to management, you will show them that. You can't just come and give them something vague or tell them that we did this and this is it. No, they want to see it. Many of them want to say it. Do you get what I'm trying to say? So great works, guys. I'm so sorry if I'm being hard on you guys, but that is just how reward works, right? So you just have to get the work done. Like just have to get it done. So that is it. So yeah, does anyone have any question for maybe any of the groups that are presented? And then yeah. Anyone? Cassie, I didn't hear anything from you. Rosemary, nothing. Sumaya, nothing. Temitope, nothing. Okay, Temitope is from GRC, I guess. Gives nothing from
Um,
you.
oh, sorry, sir. I just joined to listen.
Just join to listen. Okay.
Yes.
Um, I didn't Jadisol. I don't know whether you're from another track or something, but yeah. Ethical hacking. You guys, you are amazing. You did your best, right? It can just be better, right? It can be better. So you guys should go back, try to look at how best to present what you've done because it is one thing to do something, it's another thing to know how to present it. And I won't lie to you, the one who knows how to present is always being seen or is always being seen to be more intelligent or to be more hardworking than the one who can do the work but cannot present it. That's the truth. If you get into real world now and then you're working with a firm or an organization, it is the one who is outspoken, all right, who can do maybe little things but knows how to, speak about it, express himself on what he has done and the importance of that thing, how expedient it is, how, great that thing is, how things they can do about it. Such a person will be landing and banging promotions than you that you're just quiet doing the work, but you don't know how to present it or you don't know how to, tell people what you've done. So one of the things that is going to help your career as well is presentation. You need to work on that. And that's the essence of this presentation so that we can come together, present, and then I can give you my feedback that this is what you guys have done. This is how best you can go about it. Imagine you guys did work and you're not showing me that in your presentation. If some of you guys could have reached out to me and said, "Oh, this is what our slides look like. Do you have any corrections to make?" And I would have made those corrections for you prior to coming to present. I would have told you, you need to show this, you need to show this, you need to, but none of you guys reached out. So you guys were just doing your thing, and now you came to present, which for the presentation, I'm not taking anything out of it. It's all the presentations are great. I just felt that for your slides,
The confidence that I use to
Randy,
progress in my career.
so for your slides and okay, I think your slides and which other one again? And yeah, the way you are presenting it, like the screenshots and all of them, I wasn't seeing most of the. I think Team 2 did that so well. I think Team 1 too did something similar. So, but I wasn't really seeing, most of that in you guys' presentation. I just feel it can be better. But overall, you guys did well. All right. So celebrate yourself, please. Yeah, celebrate yourself. So yeah, Austus, do you have anything to add before we call it a night? Yeah,
Okay.
Benjamin, you want to say something?
Okay.
Hello, good evening, sir. Can you hear me?
Yeah, good evening. I can hear you.
Okay. I want to say thank you so much for the feedback to the teams. I think on a personal note, I'm learning a lot, and I feel that that's the best way to push us, even when you are hard, as it appears. So thank you so much for the feedback, and I also want to thank all the team members for their efforts also. It really showed that a lot of people put in the work. So this is not my track, so I just joined to observe. But I just also want to mention, or maybe put it in sort of a question. Since this presentation was to the top executives, and just from your feedback, it's good not to spend a lot of time on the introduction, but maybe I was just thinking it would have been good to put some top statistics, especially since we are presenting to executives, they are more interested with the business value. So in terms of cash, for instance. So for instance, it may be good to mention or give a sentence like, maybe talking of SQL injection, and then you say, because of this, it cost this other company so million, maybe 2 months ago, or so basically a relevant statistics in the business world that they can easily relate to. So if you stay, for instance, you're talking about SQL injection, instead of going deep into what it actually means, what will really benefit them more would be it cost this company maybe $200 million to settle the cybersecurity breach caused by SQL injection. Automatically, I believe you'll catch the attention of the top executives, and they may be keen on what you have to say throughout the presentation. And then also in conclusion, in the concluding part, I can see that a lot of teams also did like some recommendations and maybe further learning or tools or thereabouts. So again, for top executives, they may be more interested in what they stand to gain. So for instance, I can say, if we implement this and this and this that we've talked about in this presentation, it can save us so $1 million, or it has the potential to increase our revenue by so percentage, So again, that kind of language may be more interesting to those top executives than just saying you need this tool or you need this. Um, I hope that sounds maybe
Yeah, I mean,
reasonable.
thank you so much for the contribution, Benjamin. That was spot on, and it was a great one, to be honest. Yeah. So thank you so much for that. So as I said, these are things you can still add to your presentation that would make it relatable. Just know that see everything to be as though you are not I know some of you guys are technical, like you want to show your technical prowess and how good you are, how how bad you've really learned this thing. You've been so good and you have the understanding you want to explain. But the truth of the matter is it can really get so boring, right? When you keep explaining, we are doing this, we are doing this, we are doing this, nobody really wants to hear that. So okay, we did so thing, and then this was what we got. You show what you got. Okay, we saw this password, and then we took this password, we took it inside crack station. We None of you guys even showed me that how you cracked the password. Okay, I think the first group, wait, the first group presented on, they didn't present on SQL injection, I guess. I think they presented on XSS or something, if I'm not wrong. So for team one, what did you guys present on again? Sorry, I forgot. Let me check my notes. Lucky, what did you guys presented on? What did you guys present on? Sorry, not present.
WPA
Um,
to handshake.
oh, yeah, yeah. So yeah, you guys, I could remember you guys did something on password cracking. But for the people who did SQL injection, how about using Union to dump the user data? You dump the user data, then because I wanted to see, where you have gone above and beyond, right? You dump the user data, you get the user password, you took it into crack station, you crack the password, you give me the plain text, of the hash value that you cracked. These are things you can show to management, and they are going to see because they can see the progress, all right? They can see what you have done, and you can say, wow, so from here you can get this. And as Benjamin mentioned, you could put statistics there. Oh, so, in so year, in a particular breach, so thing happened, and it cost them so amount of money, right? So if it happens here as well, it could cost you more, and it could cost you your company reputation. It could cost you the loss of your customers in you and all of. So all of those things could be added into your presentation. It would have been so fun, like it would be so easy for us to follow through rather than just explaining code, giving us. So also I think one of the things we are going to do right now is to now embed presentation. Maybe we are not going to do just a single presentation again for the next cohort. We'll embed presentation along the line, probably like three presentations before the last presentation, so that part of the things I could remember for the first cohort we did a couple of presentation and people improved over time, so we could do
Yeah.
that again, so we can have like more than a single presentation. Then that could help going forward, right? So so that you guys will know how best to channel your thoughts, how best to present what you've done to people, so that it can really be exciting to people who are listening to you or watching you speak. All right, thank you. So yeah, Austus, do we have any other thing?
Yeah, thank you very much. And well done, the hoodie guys. We just want to say this is a big wrap. We are preparing for our graduation on the 19th of this month. The flyers will be out, and we should look out for it for the presentations and our certificates of participation. We want to bring it to your attention that if you are part of any group and you decided to abscond or you decided to run away from joining your group to present, we will hold your certificate, right? Because this is one of the criteria that you should meet before you graduate. And we want you to be on the lookout. The SOC will be presenting on the 14th of March. Time is 8 p.m. We invite you all to join. Cloud Security will be presenting on the 15th of March. That will be on a Sunday. I think time is 6 p.m. We welcome you to join us as well. So thank you all for joining, and see you soon. God bless you.
All right, yeah, bye for now, guys.